Buenas tardes. How's my sound? Buenas tardes. How's the sound? What's the quality? I think I fixed all the settings. If there's any problems with the microphone, let me know because I noticed that the jack is a little bit loose. So sometimes we might lose connectivity. So I'll be watching the chat. You to let me know if there's any problems. So today was supposed to be our review class, and I did want to have it in person, but I think it's better that we do this by distance today, and then next week we'll meet in person. I will be there a little bit earlier than 6 to set things up. If you want to talk to me after this class or before the next class or the test, just email me and we can make arrangements to meet virtual or in person. What I want to do today is finish this document. This was the discounting and inflation document, completely answer it, and then look at some problems, some additional problems, unless you have any questions about the problems and documents I've already shared with you. All right, so I'll be right there. Any comments on the sound quality? It's all about the sound. I mean, obviously the visuals are important too, but if it's treacherous to listen to the sound, it's not going to be pleasant. No, next week is the test. Today is the review. You've had lots of time. For unit 1 and 2, next week is the test. So what we did last week was solve the first two parts, and I explained, hold on. I explained what real rates were, and I introduced this, which wouldn't have been intuitive exactly, that if you have a stream of cash flows that are nominal cash flows, which is just the way that usually things are, then you use the nominal rate. So until now, I've been giving you, until this point, the nominal cash flows, nominal rate. I'm not calling them nominal, but that's what they are. When I introduced real, it's to differentiate them. So real cash flows were introduced, and I told you if you have a stream of real cash flows, you need to discount them with the real rate to find their value. And we do this when we want to focus on purchasing power and not necessarily economic conditions, right? So we want to be able to say in the future, you want to be able to have a certain amount of spending power, purchasing power. And this is the example I gave you using real dollars and a real rate. I had to convert the nominal rate given the assumed inflation rate for the next 6 years. I had to convert it to find the real rate of inflation using this formula. That's what we did here. So because of inflation eroding the value of money, it erodes the effect of any kind of interest, right? So the real rate captures the real opportunity cost of trading off future consumption for present consumption, and that's the rate we would use, 5.88. All right, so I did that, and then I said, okay, so let's do this with nominal cash flows. If we were to do this with nominal cash flows, we need a nominal rate. We have the nominal rate from the problem. We need to get the nominal cash flows. Well, how are we going to get those? Well, nominal cash flows are just the dollars in your pocket. So I mentioned to you, it's like a growth rate. And so we created them all, and we saw the pattern fits a growing annuity. So to find the present value of future cash flows, we use the annuity formula with 6 periods. So even though I didn't spell it out here, what you have is a relationship between nominal and real cash flows as well. So I'll make that an extra equation or relationship you need to take from here. So for however many periods of inflation, those would be like periods of growth from the real rate that was based in time 0, then it has to grow for that many periods. So this cash flow has to be with 1 period. This is with 2 periods of growth. If you remember, I explained that there was 1 period here, and then it was 2 periods of growth from the first moment. Put that back in, or maybe it'd be confusing. So this was really right. That's how I got 1020. So this is another formula that we need. So far there are 3 relationships I introduced. This one, the Fisher. This one about nominal cash flows. And real cash flows with nominal and real rate respectively. All right. So then you find out that you get the same value, right? Because what we did in the first case is use the real cash flows with the real rate. In the second case, we use the nominal cash flows. We had to convert them into dollars in our pockets. So we did that by incorporating the effect of inflation to compensate for rising prices. And now we have a growing annuity. Using the growing annuity formula with the first cash flow, we get this result, the same result. Any questions about this? If the screen is blurry, remember just to reload the screen. Okay, so we're going to move to the second part now. In the second part, I present you a stream of cash flows that are real, and I tell you they're real cash flows, which implies that if they're fixed, So $500. Sorry, not real. I give you nominal cash flows. I want you to convert them in the second part. Okay, so in the first part, I give you nominal cash flows and I ask you to use the regular annuity with the nominal amounts. Now, since they're nominal, in the presence of inflation, their purchasing power will decrease, and that's what you're going to see. So how many of you tried this problem already? How many of you have already attempted this and looked at the answer, solution? No one? Why don't you try it now? So draw the timeline and let me know when you're done. Very good, Sandra. So for this problem, you have 5 payments of $500 each. And you're told these are nominal. To find the present value of these cash flows, you need the nominal rate. You're told that the real rate is 5% and inflation is 1%. So you can calculate the nominal rate as 1 plus the nominal rate is equal to 1 plus the real rate by a growth factor of inflation. So the real rate converts to the nominal rate of 6.5% or 6.05%. And since these are level, then calculating the present value at time 0 is that. So using your calculator, the finance keys, which I encourage you to do, as you'll see, you're going to need to know how to use the calculator to solve the exam. And the finance keys, not just the scientific keys. You put 5 into N, 6.05 into interest. PV is what we want. $500 into payment to be received and 0 into FV, and you compute PV. And I think you get Sandra's number, right? Okay, so Sandra has it right. Alejandro, you're off by some decimals there. Or maybe you just didn't write the last decimal. Okay, so this is the answer using the nominal amounts at the nominal rate. Now do the same thing. Wow. Calculate the present value of future cash flows for the real amounts. So you need to convert cash flows to real amounts, identify the growing annuity, and use the growing annuity formula. So identify the G for the growing annuity formula, because we have to confirm the pattern of the growing annuity formula to apply it. So we'll need a G for that. And the big thing you learn here is that G is not inflation. It's related to inflation, but it's not inflation. So in the top, it was the G in the first problem. The G was the inflation. Because that was the pattern, you see? But in this one, for real dollars, with an inflation of 1%, using our relationship above for nominal cash flows, how did I write it? Let me do it the same way. R and T, okay. I don't know why I did it backwards here. So the same formula from above. The issue is this time I have the nominal rate, but I'm in the nominal dollars. I want the real dollars. Maybe I should make that more clear above too. So for this formula, I'm just going to copy it. So again, I don't like to act like I'm inventing new formulas. As much as I can, I avoided it. So I'm going to take it down here. That's what we're going to do. We're going to use this formula, this relationship between cash flows. So what you have to do is take the nominal amount and you have to like deflate it for the number of periods that have passed. So above was 500. So this is what you do. Because the inflation started right away, this is what happens as a result of inflation. You have lower diminished purchasing power by a factor of 1 over 1 plus inflation to the power of however many periods have passed. All right, so now we have to stare at this and try and match it to our formula for growing annuity. The growing annuity formula looks like right? Remembering back to the formula, the valuation is 1 period before the first cash flow, and then after that, the next cash flow is higher or larger by a factor of 1 plus G. So you wait 1 period for the cash flow and then 1 period for growth after that. And then growth continues. It continues. So this would be our C1. But then what would be 1 plus G? That's all we have to figure out for our formula. So think about that. Okay, the question was, what is the G? I had to step out for a minute. What was the G? What is the G? Let's make some space. Any clue? So what I'm trying to do, first I need my C1. So I'll take C1 as this, whatever this is. So when you divide it, 500 divided by 1.01 has a repeating decimal. It's 495.05. Well, it's actually 0495 repeating. I'll just leave that number there. I'm not going to actually, I'll have to either store it and use the stored value or recompute it to put it in the calculator. But I should not forget about those decimals. Right? Because it'll affect the answer. And I want it to be exactly the same as the part A. So if I use some rounded figure, I won't get the same answer, but okay. So what is this? So this would be then C1, 1 plus G. So the C1 part is 500 over 1.01, and that means that the 1 plus G must be equal to 1 over 1.01. So these have to be the same if this is going to be C1. Are you with me? So 1 plus G equals 1 over 1.01 means that G must be what? Tell me. And this will make our fourth formula from learning about this. That's the fourth formula from this page. So all these formulas I put in red, you can put on your formula sheet. You need to remember. So the formula sheet you can bring in for the exam should only have formula on it. Some students like to put titles. I think that's okay. You can put titles in the formulas, but not too much writing, okay? The formula sheet should have 99.9% formulas on it. You can put any formulas you want. My goal in this class is to limit the number of formulas you learn, just that you spend time learning how to modify the formulas you do have to apply them to many scenarios. So I've just written out and boxed off 4 formulas here that should go on your sheet. So solving for this, what do you get? So you get negative, almost -1. Almost -1, but it's not exactly -1. Okay, so if you use -1 in a growing annuity formula, you would have approximately got the right answer, right? But it's not, because it's not additive, right? It's growth factors. It's factors. So this is what we're working on. And it's negative. That's the other point, that it's diminishing, which we know the amount of money in my pocket goes down. This will be smaller and smaller and smaller value. So then putting this into my formula for growing annuity is all I have to do next. And I'm not going to write out this repeating decimal, I'll just use G, but I should have that in storage as well. So I'll store this in 2. So then the present value at time 0, let's use a thicker pen, is equal to C1, which I will write as 500 divided by 1.01 over I minus G. I is our rate, and since we've got the nominal amounts here, I have to go back to remember what the nominal rate is. The nominal rate was 6.05. So 0.0605 minus the G multiplied by 1 minus 1 plus G divided by 1.0605 again. And there's 5 periods. All right, so if you punch that in carefully, you should get exactly what we got last time. Now you have to punch it in, remember, because you don't have this pre-programmed into your financial calculator. Oh, and the thing that I forgot is to mention, well, I didn't forget to mention, be careful, since G is negative, don't forget the negative. If you put it in storage, it won't be hard. So let me do it for you, show you how I punch it in, and then you can try it yourself if you're having trouble. So I'm going to put my numbers in storage. I'm going to do this calculation. So 1 divided by 1.01 equals minus 1. And I'm going to store it in 2. I didn't use the store 1, but okay, so that's stored with all the decimal places. The calculator stores 25 at least, maybe more. And so now I'm going to start inside the brackets with the factor of the fraction 1 plus G. So I'm going to add 1 to that, equals, and divide by 1.0605. And I get this number. Did I do that right? So recall 2 plus 1, okay, divided by 1.0605 equals to the power of 5, negative plus 1. Now that's the square bracket. Then I multiply by a 500, divide by 1.01, and then divide by, in the brackets, 0.0605 minus recall 2, close bracket, equals, and I got the wrong answer. Okay, so I did something wrong. Let's do it again. 1 plus recall 2 equals, divided by 1.06. Oh, is it? I'm supposed to use the real rate. That's why I got wrong. Am I using the nominal rate? Let's see. I gotta go back. The real rate, no, yeah, the real rate was given, I'm using the wrong rate. Because I made the values real, I need the real rate, and the real rate is 5. So I'm using the wrong number, that's all. So we get to try this again. Let me fix that. I apologize because you know you're not all using an iPad. All right, so let's try this now. It'll work. So 1 plus recall 2 equals, divided by 1.05 to the power 5, negative plus 1, multiply by 500, divided by 1.01, and then divide in brackets by 0.05 minus recall 2, close bracket, and I got it. All right, so that wasn't bad, it took a half an hour. Questions? Thank you, Sandra. Yes, I did that wrong. Any questions about this? Okay. No questions? All right, so let's go to, unless you have any other questions, any other problems you'd like me to solve, I'm going to go to my problems, which are extra, additional. Yeah, we can, we'll do that in the problems that we do. I'd rather do them with applications. So we can do the interest rate conversions next. Okay, so I have a bunch of exercises here, unless you guys have a question from the ones I've already given you. So I'd like you to try these, and then I'll give you 5 minutes, and then we'll try it together. All right, so here's a problem. There's an interest rate conversion in there. It's not a hard one. So take 5 minutes, see what you can do, which is the right answer. These are like the problems you'll see on the test. We can look at problem 6, review 1 after this one, I guess, because I've already started. Okay, are you ready? You got something? Pick which letter. Which is your answer? Did anybody get any answers yet? Anything similar? Well, I guess you can always pick the none of the above. So what did you get for an answer? Or do you need more time? You got something? What'd you get? Which one would you pick? You need more time? Something similar to C? Okay, good. That's good. Looking good. Anybody else? Do you need more time? You're not going to benefit unless you interact with this class because it will all just be a blur. Okay, good, Alejandro. So yeah, the answer is C. The answer is C. So if you were in a rush and you chose C, you'd be doing well, but you do have to show me your calculations for the exam. Even though you're going to have multiple choice, you have to show me your method to get the points. Do the others just need more time? I have two people who tried the problem. Can I have more, please? Okay. Okay, the bank. The bank quotes the rate 6.6365, which is a quoted mortgage rate. So it's a R112. It's a stated rate. It means that they're just saying what the simple interest is over the year. But in fact, the payments are monthly for a mortgage. So you need to convert all variables to monthly rates. Or to convert all variables to months. So the first one is to make the stated monthly rate an effective monthly rate. And the way you do that is divide it by 12. So it's just it's not the simple interest, just back to the effective rate. Oh, I'm doing this all in red. going to go back to black. So you get a repeating decimal. And you can store that in 1. So that's my rate. Now, what other variables? I also have the 25 years. Which is a 300-month mortgage. What else do we have? Okay, so this is an annuity. A mortgage is a loan. It's an annuity. So the value of the mortgage, you're told, was $95,000 were borrowed. Okay, so that's the present value amount. That's what you borrow. And then that's equivalent to paying back making a payment every month for 300 months. So why am I doing this? I'm doing this because I need the payment. I need to get the payment to figure out what remains after the 15th year. So what I can do is I'll make this value 95,000. I'm not going to write it all out again. I'm just going to say this is 95,000 and solve for PMT. So go into your calculator and take 6.6365 divided by 12 and store that. And that's as a percentage. That's the rate I'm going to use for 300 periods at this rate with $95,000 borrowed, nothing in FV. I can compute the payment. So the payment should be $649.57. Now mortgages are paid in dollars and cents, so you have to round that amount. $649.57. And so now what we do is we say, well, we want to know what's the balance after the 15th year, the end of the 15th year. And I did exercises like this to find the balance. Okay, you could make the entire amortization table, but that's really a long way to go. Why don't you simply figure out the present value of the future payments at the 15th year? So that's more efficient. The end of the 15th year is the 180th payment, leaving 120 payments out of 300. So what we want to find out is the present value at one period before one period after the 180th payment. It's going to be the next payment. So the 180th payment, or the end of the 15th year, is 1 year before the subsequent payment following the payment at the 180th month. All right, so that's a lot to say, just what I'm going to write. So you're going to use the payment that you solved for same rate, nothing changed. All that changes, so you're going to use the annuity formula twice. All I'm changing is the number of periods. So there's 120 more payments after the 180th. And this will be the balance. So it's a clever way to figure out the balance. Then use your financial calculator to get the answer. And what do you get? You should get December. Clean it up a bit. Adamaris, did you fix your payment? You have the wrong payment. So there's many parts. First, converting all variables to months. Next part is to find the payment that goes into the problem. So if you get the conversion wrong, that's all the rest is going to be wrong. If you get the payment wrong, the final answer will be wrong. So make sure you write everything for partial points if they help you. Okay, let me allow you to clean that up. Let me know if you have any questions. Shall I do that review 1 problem? Before I continue with my questions. Okay, let's look at that review 1 question. It's not going to come up as nice as I'd like. Hold on. I got the wrong one. Just review 1. That's why I like to ask you to ask me before so I can be ready, because otherwise, look at all the files I have to go through. I don't know. It's not It's not so straightforward. So number 6. So due to the growing economy, investors anticipate that in 2 years, dividends on X or AXE stock will begin to experience growth that will continue at 0.2% quarterly indefinitely. So this corporation is assumed to be immortal. It's going to live forever. Oh, we're supposed to use the information from 5, so I better get that too. Let me get all this information. Let's do that again. And whoever asked the question, what is the problem? What are you questioning here? I mean, I'll solve the problem, but please identify what your question is. Because I can just solve this, but I don't know if I'm answering your question. All right, so in 2 years, oops. So after 2 years, the growth rate is going to kick in to be 0.002 or 0.2%. And that's going to go on forever. Okay. Using the information above, $5 will be the dividend. Let's put 5. Next quarter. So quarters would mean it would have to be like here. And let's make it a little bigger. So it's going to be $5 starting next quarter. And so that information, where this is the information in years, so this will be 1, 2, etc. What I need to solve this using an effective rate of 3%. Okay, so I've been given the effective annual rate of 3%, but the dividend payments are quarterly, so I need to convert that to an effective quarterly rate. So payments are monthly, quarterly. You convert all variables to quarters. So I need the effective quarterly rate, which is just I'll do it above here. So you're given the effective annual rate and you want to find the effective quarterly rate. The relationship between them is that 4 factors of quarterly growth is the same as 1 factor of annual growth. That's the relationship. So I solve this quarterly rate by taking 1 quarter in, like I partition the factor of 1 year of growth into quarters, and I do that in the exponents. It's a power effect. So I take 1.03 to the 1 quarter minus 1. And that will give me my quarterly rate. So once I have my quarterly rate, I can store that and use that. In this problem, these $5 amounts they're going to continue until after the second year. So here you're also going to have the $5 amount, I believe, because it says in 2 years they're expected to grow. So it's like after 2 years, I think. So in between that, there's 8. All right, there's going to be, I'll get rid of this and I'll calculate. So it all depends on how you draw it. I'm not looking at my clave right now, but I would say after 2 years. So I have 1, 2, 3, 4, 5, 6, 7, 8 amounts of $5, and then growth kicks in. But I can use this one and then the one with growth, the next one, as the growing perpetuity. So what I'm going to do, and I probably need to do this in the solutions, is this will be part 1. And then this, starting from here, I'll do it in black. I don't know what color. Do it in blue. And then starting here will be part 2. So this will be an annuity for 7, and then a growing perpetuity starting here. And this is what? This is the 7th quarter. So that's one way to do it. I could have done it a different way. Thank you, Sandra. So what was the nature of the question? Which part did you not follow? So this is a 5 payment annuity will be the red. and then you'll get PV0A for that. PV0, you can call it part A or the red part. And then for this, the blue, it would be PV 7/4 will be a 5, not a 5. It will be a perpetuity with growth at 7/4. If I want to use the growing perpetuity formula, I have to start one period before the first payment. So that's why I start at 7. If you start somewhere else, then you have to adjust the formula. If you started at the 8th quarter, then you would have to make this your first payment, and then you still have the same G. You just got to adjust things a bit. So whatever you do, you should get the same answer, whichever method. If you get different answers, one of them is wrong, or maybe they're both wrong. So for the red part, it's $5 over EPR 1/4, 1/1 plus EPR 1/4 to the 7, I said. And that's that. And then for the blue part, it would be $7Q or 7/4 is equal to the perpetuity with growth starting with $5, and then I, which is EPR 1/4, minus G, which was 0.002. And then the last thing to do is to take this back $7/4 to times 0. You have to discount it to get it in terms of using the time value of money to talk about that lump sum as dollars in times 0, so you can add them. And that's how you do it. If you do 6 periods, I'll have to look at what I did there. I'll be surprised if I missed one. Maybe I interpreted the growth started earlier to do 6. So maybe I interpreted it to say in 2 years, dividends on ACTs begin to experience growth. So I said by the end, maybe I started the growth here. I'll have to look what I did. Let me see. Yeah, I added the growth for whatever reason. I interpret the growth to occur before the 2 years. So I sometimes I slightly change these questions. Let's see what I wrote here. Yeah. So I let all that I did different was I interpreted as the growth was starting in the 7th quarter and happens in 2 years. And today I'm interpreting it as the growth starts at 2 years. So this is why give me your formula sheets. I mean, give me your handwritten solutions so I can have a look and see. I even give myself a different answer sometimes. So that's why I'll take your written interpretation. So I think I need to be more clear. Isn't it that in 2 years, dividends will begin to experience growth? So I could say by the end of the 2nd year, or in the 2nd year, but I said in 2 years. I don't know. It's safe to say that that's confusing. All right. So anyway, it's the same sort of problem solution. So I did 6 and 6, and here I did 7 and 7. I'll try and be as clear as possible. All right, so I'm not going to solve the rest of it, but that's how I would do it if I understood. So that's why show me your timeline and your interpretation. In 2 years, growth will kick in. I think I'm comfortable with this interpretation right now. Yeah, I'm not going to continue with that. Any other questions? I guess I have to say starting in the quarter before the 2nd year. I'm looking at 3. Interest rate conversions. What I'll do with the prep is I will open the solutions. I will open the solutions so you can see those because I don't want to spend more time on that. Oh, hold on, it didn't open. I'm having an error. Okay, so I open the solutions so you can see the prep answers. Okay, so you guys can be sure to make your timelines on the more complex problems so I can see your interpretation. Because, like I say, I even interpret my questions different occasionally. All right, so should I continue with my set of questions? Okay, try this. And then we'll do this one, and then we'll do a continuous compounding problem. That's what Sandra wants to see. So I'll give you 5 minutes for that one. Ready? Which one did you pick? After this one, like I said, we'll do a continuous compounding problem. Ready? No one's said anything. You're quiet. Did I give you my demo on how to use YouTube? How to scroll through these videos? Let me know, because I don't recall if I gave you the rundown how to use YouTube efficiently. So you're still calculating, you didn't pick one yet? So these problems are forcing you to use the financial calculator and the financial keys, and they are also preventing you from using any kind of artificial intelligence to solve. I checked all these questions in ChatGPT. They can't solve them. Doesn't mean that they're super hard. It just means that it's not straightforward. It's just layers of thinking here. Funny. It's just not ChatGPT isn't that intelligent. I don't know if they're hiding it from us. You've had a chance to try it. It's not very smart. Well, not from quantitative purposes. Are you still working on it? Have you given up? Do you want the answer? So what you can bring into the test are your calculator, your formula sheet, which could be 2 sides of 1 page of regular size paper in your own handwriting. No, it shouldn't have any photocopies on it. Should be your own handwriting. Okay, time's up. Pick one. Lucky guess. Let's see. So this is how I look at this problem. We have the value of the annuity is 40,000. And this is made up of an annuity due that's written like this. Annuity due, remember? Payments are annual, so the rate is annual. The word effective tells you it's how you want it. You want everything to be effective. The rate is stated over the same frequency as it compounds. And so the annuity due, there's going to be 4 payments, but the first one is now, so that leaves 3 in the annuity. So that's the first part. The second part is what we're trying to figure out. The remaining, so I'll move it over a little bit here. So there's an annuity later with the payment that we have to sort out for the remaining 5. So the same rate, there's 5 more. And this is all going to happen if we think of the timeline. Let's draw the timeline. The timeline is like this. And I'm out. Let's do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first I know are 8,000. That says 8K. I'll just write 8,000. 8,000. 8,000. 8,000. And the first one here. So that's 4, right? And then we want to figure out X. And because they start now, it doesn't, the last payment is on the, not on the 9th, it's one before. So having said that, this annuity starts here, one period before the first payment. So I can call it X, I can call it payment. So this will all be here at 3. So I need to discount this amount 3 periods. All right, so that's my long equation. This first part you can compute as 4 payment annuity due. So use begin mode. So we can get that value. So let's do that first. So we go to the calculator, we put the calculator second begin, second set. It's in begin mode, and I tell it that I have 4 payments at 12% of $8,000. I want the present value. Compute PV. Compute PV. Oh, what happened? 0, and then compute PV. So that's the amount. I can put it as a positive. I'm going to store that in 1. That is the annuity due part, the first part. I'm going to change my calculator back. Second begin, second set. So now it's back in end mode. So this amount that I've stored goes here. So that's that. I'm going to copy this down. And then I want to copy this. Oops. I'm going to copy this part down. And this part separately. All right, so it's always easier for me with the iPad. All right, so now what do I do? Well, I can combine these two terms here. So subtract both sides by this amount. And what do you get? So I skipped a step. I simplified this doing the subtraction, and then I cross multiplied this up here. Okay, so then this will be an annuity. So if you take this amount and multiply it, this will be the present value of this annuity that you can solve for the payment. What do you get? Julito picks B. Good job. He's right. Okay, so this is another reason why the problems are a little more complex. I want to give you multiple choice, but if it's simple, all you have to do is plug in each number to see which one works, right, into your formula. This is a little more complex because you'd have to find all this first, or you can just plug in the options. So I'm challenging you. Okay, so that's good. So then do the future value of this amount, 3 periods, or just multiply it by this amount. And then so I get 18,000. Oh, I cannot round, right? I have to keep all my decimal places. So I'm going to store that. And I'm going to store that in 2 because I stored this one in 1. In case I make a mistake or I want to check my answer. So that should equal this whole thing here. And now in your calculator, with 5 in N, 12 in interest, this recall 2 into PV, payment is what you want to find. 0 in FV, compute payment, and you get the answer, $5,000. So try that. Give you a couple minutes to clean up and get Julito's answer B. Okay, so this is all practice that you understand the annuity formula. The first part is finance. All of this is finance until now. This is just algebra. But still, in the end, understanding that this is an annuity is important so you can easily solve it using your calculator. So efficiently using your calculator when you have the simplifications we discussed. Good job, Luis. So you can round that to choose B. You round to dollars, right? Are you feeling good? Are you guys learning something? How's the sound? You still haven't told me if the quality is good. There shouldn't be any echo or tinging sounds. So what I'm going to do is, I guess you guys want these questions, hey? What I'll do is I'll post the questions. I'll post the questions so you guys have them, but I don't have the solutions written up. You have to actually, I force you to watch the videos to see the solutions. So I will post the problems after the class. Because I don't know if we're going to finish them all. So you're going to have some more to go through. Is it just good or is it a great quality, Louise? I want it to be a good quality. I want to do the continuous compounding question. Sorry, if you want to take a screenshot, if I'm rushing you. All right. So let's get the examples on continuous compounding. If I can find them easy enough. Okay. So I will just take the question. Okay. If the effective annual interest rate is 15%, then what is the equivalent annual rate compounded continuously? Now, I explained to you last class in a string of equalities that the effective annual rate was the same as e to the r0. So that is the annual rate compounded continuously. Now, there's no such thing as an effective a continuous rate compounded continuously. We don't speak about that. It's impractical. Okay, we only talk about the annual rate compounded continuously. So we've been given the effective annual rate, and we can find, so this reduces, so this is the finance part. Remembering that this amount is a limit of making that interval of compounding instantaneous. So this is the most important thing. This relationship is the important thing to you. So this is 1.15 ER0. So you want the exponent, you have to do the opposite function. That is, take the logarithm of the exponential function, and that cancels out with ln of e. So essentially this goes R0 ln of e, and this reduces to the number 1. Because it says, this says the question posed here is, what is the exponent to which you raise e to get e? So what this means is e to the what equals e, and the what is 1, because ln is log base e. All right, so if you don't remember any of that from math, you have to look back or trust me on this, and that this equation reduces to just the exponent. So R0 is equal to log 1.15. And that's it. So to put this in your calculator, you press 1.15, and then log. So the rate is 13.976. This was my answer. So have a look at that. I can also put these problems up. Did I already share these? I'm going to check the site. Oh yeah, I gave you problems. I gave you these problems, solutions. Let's just do one more and then go back to my new problems. You guys want me to do the old ones, but I want to give you new ones. All right. Let's get the next one. Actually, let's do the third one. So you know what, I'm going to copy it out. Hold on. Okay, so remembering if the statement of the rate, if the rate is stated over a different period than the compounding frequency, then you know it's a stated rate. And I use R 1 over 365 for the year compounded daily. So I want to convert now from a continuous rate to a stated rate. So again, we relate ER0 in that string of equalities to 1 plus EAR. But 1 plus EAR is also the same as 1 plus the daily rate 365 times. Those are all equal. So I can take these two, solve for the effective daily rate, and then convert it to this. How do I do that? Well, this is just a stated rate. This is just the simple interest version of the effective rate. So I have to take the daily rate and multiply it by 365 to cover the year. So the two steps are and solve for the daily rate. So I'll just do this. Again, now go from finance to mathematics. That's what you have to do. How do I put that in my calculator? You might be asking me. Oh. So you would say let's see. Okay, so you have to say 0.125 second and then E, which is above the lawn, because the second function activates the colored keys, the blue ones in my case. You might have orange. Okay, so you do 0.125 second E, 0.125 second E. So it's like 1.3133 or something like that. No, it's 1 point. And then you want to raise this to the 365, but you want to invert it and then press equals. Try that. And you get a small daily rate, which you expect. Let me just double check that I got the right answer. Okay, so I have the daily rate. I'm not done yet because I want this. I want this stated rate, so I need to times that by 365. So that's this. Well, make sure you follow the instructions of how many decimals to keep. Okay, it's 8 o'clock. I haven't given breaks, but I'm kind of giving breaks. I mean, I haven't been saying let's take a break, but I'm giving you a lot of pauses. So hopefully you don't need a break right now. We can just keep working. I want to go back to my questions. I've only done 2 of them. I want to do more. Okay. Take a screenshot if you must. I'm going to go back to my question paper. Let's get question number 3. Okay, I'm going to give you 5 minutes to do this. Go for it. Okay, which one did you pick? Very good. Do I need to do this? You guys got it? Who wants me to do it? This is great if I don't have to do them and you can just do them. It is advisable to try all the options, right? Just to catch yourself in case you made a mistake. Try and calculate all the alternatives. So anyone wants me to solve this? Is there anyone that would like me to solve this? Louise, you want me to do this? Okay. Let's see if I can do it efficiently. So you're given the rate per year compounded quarterly, which means you were given R1 quarter. So first option says that the per quarter rate compounded quarterly, in other words, EPR 1 quarter, let me do that again. It's saying to you that EPR 1 quarter is 3.2%. So let's verify that. If R1 quarter is 12%, that means that to find the effective quarterly rate, I have to take the stated rate and divide by. So the rule is, if you look back at your conversion sheet, you take the stated rate and divide by the number of compounding periods in a year. So in fact, it is 0.03 or 3%. So option A is not true. Option B is true because I can take this now and check what's the equivalent effective rate. We know that if I'm given the effective quarterly rate and I want the effective annual rate, they are related by the fact that 4 quarters makes 1 year. So if I take 1.03 to the power of 4 minus 1, I should get the EAR. And when you calculate that, you find out that EAR is equal to 12.550881%. So try that and make sure you can get that. And you could stop there. But if you have some time and you want to be sure you didn't do something wrong, you'll verify the other problems, the other options. So for C is saying that the rate per 6 month compounded semi-annually. In other words, the EPR 1/2 is 6%. So you can use any of the ones you've already calculated, but you should go with the original one in case you made a mistake. So given the quarterly rate, let's find the semi-annual rate. Think about their relationships. Their relationship, which one is smaller? The quarterly rate is smaller. In a quarter, there's 3 months. So, 2 quarters make a half, right? So this is the relationship between those two. So you can use the 3% that you found here and check if the semi-annual rate is 6. And it's not going to be, right? Because I can already tell it's not going to be, because we're compounding, we're not multiplying. So this is 1.03 squared minus 1 is the semi-annual rate, and that's not 6%. It's 6.09%. Okay, so that C is wrong. And finally, you were told that in D, the per year rate compounded every 5 years, which is an R, that is compounded every 5 years, you would write it like this. And it's per year compounded every 5 years. Should be 16.2%. All right, so how are we going to get that? Well, all the stated rates are related to the effective rates with that expression that I showed you, that EPR to the subscript n is equal to R subscript n divided by number of compounding periods in 1 year. So the subscripts are usually fractions of a year, but this case we have years, not, fractions of a year. But that's fine. We can still use that. The conversion is actually going to be using the 5 year. So this means that the interest is compounded every 5 years. This means that it's compounded every 5 years, but I want the simple interest statement of 1 year of that. And then this means the number of compounding periods in a year. Well, 1 year is just 1/5 of the 5-year compounding period. So that's how you would do that. So what we need to do to find this amount up here is take, basically we have to solve this, we have to take the 5-year rate and divide it by 5. So it's just the idea of R is just, it's always stated over a year. Now this is over 5 years, so we're going to do a simple thing and just divide by 5 to find what it is equivalent on average in a year. So I need EPR 5. How am I going to get that? Well, just like I did the others, I use the rule or the relationship I want EPR5, and I have the EAR, I have the EPR 1/2, let's go back to this one in case I made a mistake somewhere. Let's use the quarterly rate. So how many quarters are there in 5 years? That's what you have to think about right now. How many quarters in 5 years? There are 20 quarters in 5 years. So I will take 1.03 to the 20 minus 1 to get EPR 5. Good. And then we have to chop that up into, to be a stated rate, we just divide. If we have to get an effective rate, we have to put it in the exponents. And it is 80%, right? Because it's over 5 years. It's 3% over the quarter, it's 12% over the year, 12.55. And in 5 years, it's compounding 12% a year for 5 years. It's actually 80%. And so to find our final answer, divide by 5. It's not just 16.2, it's 16.122. So this is wrong. It's close, but it's not the right answer. Okay, so that's why B is the right answer. Ready for the next one? So you can review these. You have the videos. I'll post the question paper. Let's keep going. If you need to take a few hours just to focus on interest rate conversions, you can do that. Go back to the questions. Feel confident going to the smaller intervals and to the larger intervals, compounding. I'm going to skip number 4. Let's try number 5 before we go. 5 and 6 are similar. Okay, I'll give you 5 minutes to set that up, and I'll check back in. Are you ready? How's it going? Do you get an answer? A, B, C, D? No, no choices? Okay, so this is another one with dividends. So we want to value the stock. Sounds familiar to the one that we did earlier, right? So in 3 years, so by the end of the third year, 80 cents will be paid per share. And then the quarterly dividends will increase at a rate of 2% per quarter until the end of the 6th year. So G initially is 2%. So this is going to be 0. These are in years. And we have 4, 5, and 6. And that goes forever after. So at the 6th year, and the 6th, then it begins to grow at 1.2%. And forever. Okay, so this company is not going to fold. This is going to exist forever. That's the assumption. And we're going to use those approximate growth rates to estimate the value of stock, the value of a share. Now, payments, the dividend payments are quarterly. So you need the effective quarterly rate. And now that you have the hang of it, given the EAR, you have to divide it into, you have to partition it into 4 parts minus 1, right? So that'll be the rate that we store in our calculator. So I'm just going to lay this out and then let you go because it's late. I'll give you the answer. You can try it yourself. All right, so we're going to store that value. So this amount here will lead to, well, this will be the first one. So valuations occur 1 quarter before, or 1 period before the first payment. So in quarters, that would be, you could call this PV 2 3/4, or you can speak of this as 4, 8, right? 1 less than 12 is 11 quarters. 11Q. And the first one would be 80 cents. And then it'll grow. So this is a growing annuity between here and 6. So this is an annuity with growth in the blue. And how many payments? So we have to count them. So there's going to be 4 in here, 4 in here. So, right. So it has to be. So this is an end-to-end inclusive payments, right? So excluding this for a moment, you're going to have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's 12 plus this one. 13 payments. Is that correct? So how would you figure that out? If we did this, let's look at this as this is the 11, this is the 12. So these blues are in quarters. Well, let me use a different color. Let me use red. So this is the 11th quarter, this is the 12th quarter, this is the 24th quarter. Okay, between the 24th, between the 12th quarter and 24th quarter, inclusive. Now at the end of the notes, at the end of Unit 1 notes, I explain when you want to count the number of payments between 2 periods, end of period tick marks, end of period payments, you need to consider that it's not about intervals. We want to know about payments. So we have to do 24 minus 12 plus 1. In other words, 13. Now you can see it when you mark them and you write them out, but what if this was a longer duration and you might get confused anyway. But that's how you can figure out if you're going from this end all the way to here. So there's 12 payments. So we're going to say that 13 payment annuity with growth. And then you have to figure out what the payment is here. Because then the growth kicks in. So what is the payment here that can go into the perpetuity form? Because that's what you have here. So this is a perpetuity with growth. And you can start with, this is the first payment, and you can you work with the PV of it there. 1 period before the first payment. So that would be at the 24th quarter. So to figure out this payment, you have to think about 80 cents accumulating for 12 periods. In other words, there's 11 intervals of growth, right? Because it starts with 80 and then the growth kicks in. So there's 12 intervals, but one is, the first one is where the growth kicks in. So you're going to have a power 11 over here on this one. So what you're going to have for that payment is going to be 80 cents, 1.02. Okay, I'm running out of space. Let's do that again. I'll make it in black. $0.80. Then you have the 2% for 11 periods. And then you have one period at 1.12. I believe that's going to be the payment here. And then you put that in the perpetuity with growth formula using this rate. Now this has to be discounted 24 quarters. This one has to be discounted 11 quarters. And I will just erase this. So this is an annuity with growth. This is the growth rate, 13 payments. That has to be discounted 11. This one is a perpetuity with growth, first payment this amount, and discounted 24 quarters. And you add them together and figure out with this rate which one is your answer. And your answer is going to be, let me tell you, Adamaris, I said there are 13 payments, 12 intervals, but 11 with growth. Not sure your question. I'm not sure of your question. All right. So what's the answer? Let me see. Well, did I answer your question, Adamaris? It turns out that it's none of these, but I think you should try and get the answer. I will post the answer so you have that to study from, okay? I actually don't see. I have to check. Where's my final answer? But it's late. So I will post these two and I'll put the answer for this one. I think that's my only none of the above selection. Well, maybe I found it here. I did find it. Okay, it's 2509. But you know what? I'm going to double check it and post it. I'm going to double check this because it looks a little bit different than what I just told you. Okay, so I'll post that before I sleep tonight. So with that, I'm going to sign off. It's late. Thank you for sticking around. I hope that helped. If you have questions during the week, just get in touch with me and we can look at that virtually. I will be away on Thursday and Friday and Sunday, but you can contact me for Saturday or for Monday. We can get together and look at your questions or any time on Tuesday. Okay, so good luck studying, or text me or email me and I can work with that. But in terms of meetings, I won't be able to meet Thursday and Friday because I'll be at a conference, and Sunday I'll be away. So have a good night. I'll post these for you so you can continue studying. Thank you. Me too. I hope I recover soon. I don't look so great.